Hi, welcome to Lab 1, Charge Tapes. We're going over the idea of charge and property of matter, making estimations and simplifications of assumptions, the amount of excess charge on everyday objects. We're going to be using rub to clear tape to observe its interaction with different objects. To go over the basics, Newton's second law is the net force equals mass times acceleration, which in this system, the net force is going to equal 0 since the tape is floating. The two forces applying to it is going to be the electric force and the gravitational force. The electrical force is going to equal the negative of the gravitational force, and the gravitational force equals mass times gravity constant, which is also negative. To the top of the right, we have the free body diagram of the floating tape. The third law is a law of action and reaction. Every force has an equal and opposite reaction, especially when the net force is equal to 0, meaning any forces have to be opposite of each other, such as if you have two forces, they have to be opposite each other. Coulomb's law is where the force of electricity equals K, the constant of K, with the Q on tops right there. Coulomb's law is the force of electricity. The equation is on below. And in this system, we need to have the measurement of length since we are given the mass per meter. But since we're giving the mass in grams, we need to change it to kilograms for our equation. So here we're going more in depth on the given information and the data we already have. So the length of the tape is going to be 2.2 meters, and since we have 1 gram per meter, we can use that to figure out that we have what mass we have. Then we have figured out the distance between the floating tape and the other one, and the distance was 0.004 meters. Using that information on the left side to the bottom, we can figure out the gravitational force and the electrical force. And in the blue box, we find out the Q of the equation. And these are also going to be used and found in the code, which is the next slide. This is my program. It is the same math that was on the previous slide, and basically we are finding the force of electrons and force of gravity, and we're using that information to find Q, which is the charge of the tape. And using the charge of the tape, we can divided by the charge of a single electron, we can find the number of electrons within our tape. And finding the how many atoms are on the sticky side of the tape by the length and the width of the tape times the single length of a tape. We're making the assumption that the width and the length of an atom are the same. And with that information, we can find the ratio of the number of electrons over atoms. Here is the result of my code, where force of electricity is pointing upwards and force of gravity is pointing downwards as it's negative, and the charge of a piece of tape is 1.867 times 10 to the negative 9th, and the assumptions we're making is to treat a long tape as though it were as a single point charge with all charge concentrated on the center of the long tape, and assume that each U-tape you have made is about the same amount of charge evenly distributed along the length of the tape, which is why Q1 and Q2 were the same. And Here are some
Here are some
questions from our
questions
lab
in our lab
instructions.
instructions. If
the tape was positively charged, how would we react with the negatively charged pin?
Plastic
Since
pin,
opposite
will
charges
it
attract each
be
other.
attracted?
If the tape was negatively charged, it will be repelled from the negatively charged
the same
pin,
sign.
since opposite
If
charges repel
the
each other.
tape was
If the tape is
neutral,
neutrally charged,
then
it would also be attracted
polarized
to
by
the
the
negative
because it
charged
polarized,
pin,
and
as the positive
the
charges within the
tape
tape would
is
be attracted
normally
to
positively
the
charged
negative
in
charges
slab,
of the pin,
since it's been
and
attracted to
the
negatively charged pin
negative
and
charges would be
neutral
repelled.
objects, and
Proven in our lab.
the tape is positively charged as it's attracted to a negatively charged pin and neutral objects. Also, our lab proves it. It is important to handle the charged tape as little as possible because it can change the charge by losing or gaining electrons. What happens is electrical charges are positive and the protons are negative. Well, the signs would be swapped, but the objects that repel each other would still repel each other, and signs that attract each other would still attract each other because they're opposite signs.